Hey you guys, this is Mr. Sal. This was one of the questions from the homework in Module 3. So thanks for those who actually reached out, just emailed me and let me know that they had some concerns about this problem, some questions about it, so we're going to go over it all together. So just reading this, an online dealer found that in April 2007, there were 4,920 purchases, and in November 2007, there were 5,200 purchases from their website. Purchases followed a linear model in the form S of t equals 𝑟𝑡 plus I, where S of t is purchases in thousands and t is months, where January 2007 equals 0. So we need to keep that in mind, probably not until we get to the end of the problem, that this is in thousands of purchases. Now we could change up here, this could be 4.92 purchases. For example, because that would be 4.92 thousand purchases. And then this could be 5.2 purchases right here, 5,200. Again, I'm not going to worry about that because I'm going to solve this problem regularly and then change it at the very end. So part A, how much are the sales changing on average? So on average, we know that they're changing, for example, we started recording this data apparently at 4,920 purchases, and then it ended at 5,200 purchases. Now I just want to find the difference so we can figure out how much it did change, and when I subtract these two, I find that it changed by 280 purchases from the website. So 280 purchases, and that would be, it looks like, from April to November. I don't know about you, but for me, I'm going to have to use my fingers on this thing. And April's where we're starting, so that's going to be considered 0 for me. And yes, I know that it says T in months where January is 0, but I'm just trying to figure out the change in this. So how many months changed from April to November? That would be May, June, July, August, September, October, November. So that's 280 purchases, and for me I counted 7 months on that. So 280 purchases in 7 months on average. 280 divided by 7, that'd be 40 purchases per month. So we have that labeled properly now, 40 purchases per month on average. Part B says write the linear model function with the parameter values. Now, up here it already tells us that we want S of t, right? So I have S of t equals R, that's the rate, and we already know that's happening at 40 purchases every month. So if you took 40 times t on average, that should tell you about how many purchases they're having after a certain number of months. But then we got to figure out how much they started with. Now our starting value is in January of 2007, right? Because that's where it's 0. So we're going to have to backtrack from April or November. It's not going to matter. We could use the formula for finding the Y-intercept on this one, but again, we can just do this the old-fashioned way as well. So I'm going to take the 4,920 purchases from April, right? And to go back a month, I'm going to have to take off 40 purchases, because that's what's happening on average. And that would give me 4,880 purchases. And again, going back a month, that would be March. And continuing backward, I would have to take off another 40 purchases, and that's going to take me to February. And then finally, taking us back to January, would have to take off another 40 purchases, which is at 4,800 purchases in January. So going back to the equation, we've got that S of t equals 40t, and then from there I can put in that plus 4,800 like this. And that would be the function for that one. Now, it's not the full function because we know the purchases are in thousands. But again, I'm going to change that at the very end. So I'm going to continue to use this exactly the way that it is. So I'm going to go on to part C and then come back what does the model predict total purchases will be in October 2010? So I'm going to rewrite the function, and I've got S of t equals 40t plus 4,800. And this one says how many total purchases will be expected in October 2010. Now this is where things get a little tricky because October 2010, right? We're looking at starting this data from January 2007, and that was month 0. Now this is where things get a little tricky for us because things are a little offset because January 2007 is month 0. So I'm going to show that down here, right? January 2007 is month 0, which means January 2008 would be 12 months later, and then another 12 months later, January 2009, that'd be 24 months later, and then another year later is another 12 months, which puts us at 36 months just to get to January 2010. Now we are trying to make it to October 2010. So each of these months is just another month, meaning February is month 37, March is month 38, and so forth. And we can see right here at the bottom that October 2010 is the 45th month. So when solving this with the function that we were given at the beginning, or that we solved in part B, the first thing I'm going to do is go and replace the t values with the number of months that October 2010 is in this problem. And again, just going back, we know, based on what we just found, that that is the 45th month. So in that function there, I've got S of 45 now instead of t, because we know the t value is, equals 40 times 45 plus 4,800. Now the great part about C here is that once I get this solved, it's finished. It's just asking how many purchases. If we use the actual function in part B, which we're going to change here in a moment, then we would get something a little bit different and would have to make the second conversion. But we don't want to do that right now, which is why I have not shown what that value is or what that function is yet. All I'm going to do at this point is solve this problem. So I've got 40 times 45, which is 1,800. And then I'm going to add the 4,800. And now we've got S of 45 equals 6,600 purchases. And that is going to answer part C. Now for part D, in what month and year does the model predict sales will be 6,840? So here's one thing we know is that 6,840, just to start out, is looks like it's about 240 purchases more than that 6,600. So one way to do this, and I'll show two different ways for this one. One way to do this is just to find the difference, right? We know that we're looking for 6,840, and right now, at the end of October 2010, it was 6,600. So again, that shows a difference of 240. Now, it's 40 purchases every month, so we're going to divide that by 40, and that appears to be 6 more months. So 6 months after October, that would be November, December, January, February, March, April. And we could figure it out that way. Then the answer to this one is April, and that would be in the next year. So 2011. And that would be the answer for D. Now, that's one way to do it. Another way to do it is to take the formula or the function on this thing, and we're going to replace S of t in this case because that tells us how many purchases were made. And in this case, we know that it was 6,840. And we can solve this like we would a regular equation. So I'm going to subtract 4,800 from both sides. And I have 2,040 equals 40t. And then I'm just going to divide both sides by 40. And that gave me t equals 50. So 51 months after January 2007 would be the month that 6,840 purchases were made. Now, here's another thing we know is that at 48 months, which would be 4 years after January 2007, that would be January 2011. Now, it would be 3 months after that, so you'd be looking at February, March, and April. So again, this is doing it a little bit different, but it helps us to keep track of this stuff. April 2011 is the month that we would find a total sales of 6,840. So that was a lot of work on that one. We're still not finished because we got to change Part B into thousands of purchases. So this is the formula from Part B, but since we just want to change this into thousands, what I'm going to do is I'm going to move each decimal place to the left 3 times. So 1, 2, 3, this would make that 0.04. If you want the other 0 in there, that's fine. T plus, and this would be 4.8. So S of T equals 0.04 T plus 4.8. And there we go. I have that replaced now in Part B. So this is all of our work for this problem. I know it's quite a bit, but thanks for watching. I hope this helps you guys out, especially with this one homework problem. I know a lot of people spent at least an hour even on this thing. So again, I hope this helps. If it does, thanks for watching. Please like and subscribe, and just leave a comment below. Talk to you guys in the next one.